Hello, my name is Omar Muhammad from grade 9B1. In this video, I'm gonna explain mine and Ahmed Wael's Term 3 Physics Performance task conducted by Mr. Lawal Ezekiel about the effect of gravity on Earth and space. Starting off with an introduction that explains what's the effect of gravity on Earth and space. Gravity is the force by which a planet or an object exerts on another object to pull it into its center, and this is the force the force that allows the sun to pull the planets in orbit, and also the same thing with the moons, where planets keep them in orbit. Moving on to the first question: how do we compare the gravity on Earth to the other planets? Gravity is dependent on mass, where everything from stars, planets to subatomic particles have mass, so they are all attracted to each other. And depending on the size of an object or planet, the gravitational force it exerts on other objects varies. So, if the object is larger, its gravitational force will be stronger, while if it's smaller, the gravitational force will be weaker. For example, Earth's gravity is equivalent to 9.8 ms per second squared, ms squared. This means that an object, if held above the ground and let go, will accelerate towards the surface at a speed of 9.8 meters for every second of free fall. This is the standard for measuring gravity on other planets. And on the other hand, Jupiter is 10.97 times the size of Earth, while its mass is equivalent to 317.8 Earths. As a result, Jupiter's surface gravity is 24.79. To the second part of the question, in accordance with Isaac Newton's law of universal gravitation, the gravitational attraction between two bodies can be expressed mathematically as F, the force, equal gravity, the gravitational constant multiplied the mass 1 and the mass 2 divided by the distance between the centers of the masses. Second question: what's the effect of gravity between mass and distance? Since the gravitational force is directly proportional to the mass of the both objects interacting, more massive objects will attract each other with greater gravitational force. So if either of the masses increase, the gravitational force between them will also increase. On the other hand, if the gravitational force is also inversely proportional to the square of separation distance between the two objects interacting. So, if the distance between the objects increase, the gravitational force will decrease. While if it increases and they move closer to each other, it will be stronger. And here is a small example. Similar to gravitational force, if you placed two magnets with different sizes and masses on a table, the magnet with greater mass will attract the smaller one to its center. And as you move them away from each other, the magnetic force will be weaker. And similar to gravitational force, if you move in, closer to each other, it will increase. Third question: explain the factors that gravitational force depend on. Gravitational force simply, as we said before, it depends on two factors, which is the mass and distance. And here is a picture, and where we explain how the apple that fall down on Isaac Newton was like because of gravitational force, where gravitational force was pulling it down to the ground in resistance with the inverse, the opposite force that was moving, like the resistant force against gravitational force, and this also implies that Newton's relates to Newton's third law, which states that whenever two objects interact, they exert equal but opposite forces in each other. Fourth question: analyze the relationship between Newton's laws of universal gravitation and Kepler's laws of planetary motion. Here are the Kepler's three laws of planetary motion and Newton's law of universal gravitation. Kepler's laws and Newton's law taken together imply that the force that holds planets in their orbits by continuously changing the planet's velocity so that it follows an elliptical path that is directed towards the center from the center of the sun from the planets. 2 is proportional to the product of the masses for the sun and the planet, and 3 is inversely proportional to the square of the planet-sun separation. Now to the final question. What are some applications of gravitational force in real life scenario? This is a pretty easy question because gravity is everywhere, and some of the examples are that it's the force that pulls the ball down to the ground when we throw it, what allows the box or any object to stay on the ground without moving or flowing. It also allows us to pour drinks. Here are also some extra examples. Finally, here are small, some helpful links that will allow you to gain more information about this topic. Finally, the conclusion. We all know what's gravity and what are the factors it depends on. We also learned that Newton's law of universal gravitation and how is it related to Kepler's laws of planetary motion. And using all of that information, we were able to list some real life scenarios where gravity is the force causing the action. That's it for our project. I hope you enjoyed and it's a good one. Thank you and have a nice day.